Okay, we are continuing with Unit 10. We are continuing. We did not finish it yesterday. We are continuing with Unit 10, starting with number 12. Okay, so taking a look here. When I rewrite this, I write 18 to what power? 3/4 or 4/3? 3/4 times 18 to what power? 4/6 or 6/4? The power is always at the top, so 6 over 4. Do you guys agree? Yeah. Equals. Good question. Can we reduce and then add? Yes, you definitely can, but why would I not want to reduce and add? Because they already have a common denominator. What's 3/4 plus 6/4? So do I multiply the 18, or does the 18, the base, stay the same? Stays 18 raised to the what? 9/4 equals 18 to the x/4. Now, if the bases are the same, that means the powers must be equal. What is x so that 9/4 equals x over 4?
X equals 9.
X equals 9. Definite test question. Questions on this before we move on? Okay. Next one, 7 to the 5/12 over 7 to the 1/3. All right, where did I get the 5/12 from? And why is it 5/12 and not 12 over 5? Anyone? Where did I get the 5/12 from?
From the 7 and the 5.
From this here?
The first one.
And it's always the power over the index? Okay, what do I do to the exponents? Over here I added them. What am I going to do here? I heard somebody whisper it. Subtract. Okay, now when we subtract, when we add or subtract, do we need to find a common denominator?
Yes.
Yes, so I do 5/12, take away 1/3. What's my common denominator going to be? 12. This stays 5/12. 3 times what is 12?
4.
So when I multiply the top by 4, what do I get? Add them together. What does that equal?
No.
Yes?
Yeah.
Sorry, subtract them together. Thank you. Subtract them, and what do we get? 1/12. All right, so 7 to the 1/12. Take away 7 to the 1 over x, or equals. Since they are the same, since the bases are the same, the exponents must be equal. So what does x equal so that 1/12 equals 1 over x? X equals what? 12. Questions? All right, I'm going to fill these in. This was true, false, true, false. We did those yesterday. Do you guys agree those were the answers that we came up with? If you will check the others as I write them down and make sure that they are what we came up with yesterday. So far, so good? I didn't finish this one with you guys. I told you guys to finish it on your own. Can anybody tell me what it came out to be? Perfect. Root 13?
No. Oh, yeah.
Okay, it's okay. 2 minus 7 root 13. Then we just did these two today, 9 and 12. Questions on this page before we move on? All right, page 13. This is still going over the stuff that we've been doing that we reviewed yesterday. What do I do with a power to a power? Add or multiply? Multiply. Now I have two pieces in here. What do I put on the 8 as the exponent since there's nothing there? And then what do I do with the 2/3? What's the math word?
Distribute.
I treat it like a distribution. Okay, so 8, and I multiply the powers. What is 1 times 2/3? 2/3. And then x to the, what's 2 times 2/3? 2 over 1 times 2 over 3 multiplies to what? 4/3. All right, now they're asking us to find all the ones that are equivalent, all the ones that are the same. Let's check this first one. So I could get it to look like this, like this. I can even get this simplified even more. We'll check that as we go. All right, because of the parentheses, is that squared being applied to both of them? Yes. So it's 8x squared parentheses raised to the 2/3. Do you guys see where the 2/3 is coming from? Yes? Power of 2, and then the index is 3. And because it's in parentheses, the whole thing's being raised to the 2/3 power. All right. As your answer? Okay, well, there's probably more than one answer. So let's check it. Is this the same as the original one they gave us? Yes or no? Yes? So is letter A an equivalent expression?
No.
Yes?
No.
Ask me your question, Christina.
Oh, number. Okay. We just put it in exponential.
Yes, I put in exponential form. So is A an answer?
Yeah.
All right. Next one. It's really important that you recognize, because I had a few kids struggle when I did this with one of my classes yesterday. I'm just going to write it bigger so I have more room. Okay, when I have this, what is the, okay, first off, is this 4th power applied to the 8 or just the x? Okay, this one over here, the 2 was applied to both the 8 and the x squared. Why is that? Parentheses. Do you see that this one has no parentheses? All right, so what's the power on the 8 that I don't see? So when I write both of these with the 3, this is going to be 8 to the what? 1 over 3. And x to the what? 4 over 3. Do you guys see how I got that? Because there's no parentheses around this here, the 4th power is only on the x, it's not on the 8. So I need 8 to have its own power. What is it? It's a 1. 1 over 3 for the 8, 4 over 3 for the x. Does that make sense? All right, so I'm going to write that here. There was a 1 here. So it's 8 to the 1/3 and x to the 4/3. Is that the same as this one here? The x to the 4/3 match, but 8 to the 2/3, is that equivalent to 8 to the 1/3? No. So B, unfortunately, is not an answer. All right, next one. Is that you? Okay, please stop. All right, so taking a look. This is the one that was the harder one on the test. I'm going to simplify this first to see if I can get it to look like, what number do I have here? 4. All right, so I'm going to do it here. How would I rewrite this in radical form? What's here that I don't see? Not yet anyway. What am I going to put? The 3. And what's my power? And what's easier to do first, the squared or the cube root? Cube root if you can. The radical is always easy to do if you can first. What's the cube root of 8?
2.
Is 2 my answer, or do I have to still square it?
Square it.
Which is 4. Is that equivalent to that 4 right there? Yes? All right. Now I'm going to change x to the 4/3 to radical form as well. And when I do that, I'm going to change the radical. What's here? 3. X to the 4th. Okay. I've said radicals are easy to do first. Can I take the cube root of x without knowing what x is? No, and there's not enough anything to take out because it's just x. So think about it this way, and I have told you guys you can write it both ways. Are those two things the same?
Yeah.
What does this mean right here? How many x's do I have? 1, 2, 3, 4. Do I have enough to come out as one chunk? What do I circle in Twos or threes?
3.
The cube root tells me to circle in chunks of 3. So 4 stays 4. What's coming out?
3.
X. And then cube root of what's staying in? X. Okay. So what I did is I just found another way to write this as 4x cube root x. So it can be written this way. It can be written this way. And this is equivalent to 4 cube root x. Where did the 4 come from? 8 raised to the 2/3. Cube root of 8 squared, 2 squared, 4. Where did this come from? This piece right here came from x to the 4/3. Cube root of x to the 4th. Expanded the x's, took one set out. X cube root x. I know that's a lot to digest and a lot to take in, but we have the tools. We've done them before. Is this equivalent? Yes or no? I'm sorry, I was on C. Is this equivalent? Yes or no? Yes. All right. Now, even though it may not be in simplest radical form, is this the same to this one right here? 4 cube root of x to the 4th. Yes? They didn't simplify it, but is it still equivalent? Yes. All right, and the last one, bless you. We're going to do the same thing that we did earlier. What's the power on the 2 that I don't see?
1.
And do you agree that 4th power is not applied to the 2, just the x? Okay, so each one has its own exponent. So x to what power? 1/3, and I'm sorry, it's not x. It is 2 raised to the 1/3, and x raised to the what? 4/3? Okay, does it look more like the first? I mean, if I'm going to compare them to 1, would I compare it to the first, the middle, or the last? Which one should I compare it to? The middle. X to the 4/3, does it match? Yes. And x 8 to the 2/3, is that equivalent to 2 to the 1/3? No. No, it is not. 8 to the 2/3 became what when we simplified 8 to the 2/3? What did it become? 4. And is 2 to the 1/3 ever going to become 4? No. So is this one equal? No. So what are my 2 answers or 3 answers? A, C, and D. Again, a lot to digest, a lot to take in. Remember, I will be posting these online, so you can go back and look at it again, but it is something you do need to know how to go through on your own. Okay, questions on 13 before I move on to 14. Okay. 14 kind of has the same concept that we were doing on these two, these two. Is that squared applied to the 2 and the x or just the x? So what's on the 2 that I don't see? What power? So it becomes 2 to what power? 1/4, and x to what power? 2/4. And then this has also a power of 1, so it's 2 to the what? 1/4, and x to the... Okay, I'm going to look at my answers. None of them look like that. So it looks like they combine like bases. Do you agree that these two have like bases? And these two have like bases? What do I do with the exponents when I'm multiplying like bases? Let me rewrite it. 2 to the 1/4 times 2 to the 1/4 times x to the 2/4 times x to the 3/4. When I'm right here multiplying like bases, what do I do with the exponents? Add. And when I add, do I multiply the 2 times 2 to get 4, or does it stay 2?
Oh, no, it stays.
It stays. And I ask that because kids are still making that mistake. And do you think that's why they wrote it like this the way they did? As a distractor?
Yes.
Yes. All right. So we leave the 2 the same. 2 times 2. We don't multiply. It stays 2. But we add 1/4 plus 1/4 is 2/4. We'll reduce later if we have to because sometimes they do not. And then 2/4 plus 3/4 is what? 5/4. All right, without reducing, can anybody tell which one matches? Oh, and did they reduce? I did say that sometimes they do not. Did they reduce? What letter is it?
B.
B. 2/4 can be reduced to 1/2, but they did not. X to the 2/4, I'm sorry, 2 to the 2/4, and X to the 5/4. All right, I'm going to, questions on that one before we move on. Okay, next one, select an expression equivalent to this. I'm going to rewrite it because multiplication is commutative. 1/3 times 1/3 times x to the 1/4 times x to the 2/3. All right, I'm gonna give you guys a few seconds to do that one on your own. Now, technically, on the 1/3 and 1/3, they are like bases, but I would just multiply them since there's no powers. What's 1/3 times 1/3? 1/3 times 1/3. Multiply the numerators, multiply the denominators. 1/9. Coefficients 1/9. What are you gonna do with your other two exponents? Add them. I'm gonna do that now. And is there a common denominator? Not yet. You have to find it. Okay, you ready? Yes. Yes. Okay. You guys said, I told you guys to add. Has anybody done that already? What did you get when you added those together? 11/12. Your common denominator would be 12. Multiply top and bottom by 3. Multiply top and bottom by 4. Okay, so then I have 1/9 x to what power? 11/12. All right. None of the answers are written this way, so it looks like they rewrote it in which form? In radical. And I heard somebody say it. Which one is it?
Radical.
Is it C?
It is.
1/9 stays 1/9. And is x to the 11/12 the same as the 12th root of x to the 11th power? Yes. All right. I think we've done enough of these together. I can either skip it and let you do it on your own, or give you guys a few seconds to do it right now and then check it together. I just leave them. Yes.
Can you go over
18 instead? All right, so you guys can do 17 on your own?
Yeah.
Can anybody tell me what you would do or what you did do already? Change them to exponential. So this one's already there. And the next one becomes what? 2/4. And then what would you do?
Multiply them.
Multiply the 5 and the 5?
Uh-huh.
Do we ever multiply the bases? No, what do we do instead?
Add them, or keep them the same.
Keep them the same and add the exponent's common denominator. All right, number 8.
Oh, wait, so
Teen.
it'd be 5.
It would be 5 to the whatever you get when you add 3/8 plus 2/4.
Wait, are we not doing the 16?
Did I skip 16? I did. Sorry, I did not mean to. Do you guys want me? You know what? I'll talk about it, same as this one, and then you finish it. Okay, I'm going to distribute. Do you guys see that it's a distribution problem?
Yes.
Yes? 8 to the 1/3 is getting distributed to both. 8 to the 1/3 times the cube root of 8 squared plus another 8 to the 1/3, but this time times what? 8 to the second power. I'm going to put that as 2 over 1 just so I remember it's a fraction. Okay, second piece is easy because it's already written in the proper form. What are you going to do with the exponents? Add. First one, it's not, which one do I have to change in order to add the exponents? First or second? Do you agree I have to change this one? 8 to the 1/3 will stay times 8 to the what power?
2/3.
Thank you, to the 2/3. And then you can add them both on your own. So 1/3 plus 2/3, 1/3 plus 2 over 1. You can add them together. Only when you're multiplying do you add the exponents. All right, I'm moving on to 18. Questions on 16 or 17? Okay, from the numbers, blah, 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 choose two numbers that when you multiply them, it is irrational. And when you add the same numbers, it is rational. Irrational, rational, multiply, and add. Okay, when we multiply them, we want them to still have a radical. But when we add them, we want the radicals to cross out or undo each other, or actually in this case, cross out. All right, anybody have two of them? That when you multiply, it stays irrational, and when you add them, it becomes rational. Anybody think about how you can add two rational numbers for it to become, and repeat it, how you can add two irrational numbers in order for it to become rational. For example, is root 5 plus 2 root 5, is that rational or irrational? Is that rational or irrational? Okay, but I want to add them so that it can become rational. What's the only way that's going to happen? Root 5 plus negative root 5, does that undo each other to become 0? Yes. All right, so what if I put a 2 here? 2 plus root 5 plus negative root 5. Would those cancel out and give me 0 plus 2 or just 2? Rational or irrational? Okay, so this is what I'm trying to do. I'm trying to add where the radicals cancel each other out. They're opposites. So can you give me two of them here where that would happen? I only see one that has a negative. That's this one here. So 2 minus root 7 with what other number? 7 or root 7? Okay, we're going to check it. What did it say first? When you multiply them, it is irrational. Root 7 times, what did we say was the other one? 2 minus root 7. What happens when you multiply this? What's the math word I'm looking for here? Distribute. What's root 7 times 2? Minus, what's root 7 times root 7? You're multiplying here. What's root 7 times root 7? Root 49, which is 7. Put your phones away, guys. You shouldn't have them out. This is your biggest grade of the year, so put them away and focus. All right, rational or irrational? Why is it irrational? Because it still has a what? A square root. It still has a square root in there. So did that work? Did we multiply and get an irrational? Yes or no? Okay, but when we add these same numbers, root 7 plus 2 minus root 7, what happens with the root 7s? They're like terms. What happens? And I'm left with what? Rational or irrational? And is that what happened? When I add the same two numbers, it is rational. All right, yes.
Could you just do, oh, never mind.
These two, root 7 and 2 minus root 7. All right, multiply them. So now again, we're multiplying. but this time we want them to be rational when I multiply. And when I add them, I want them to be irrational. Let's look at the multiplying. Actually, yeah, the multiplying and rational. How do I multiply two numbers together and make them rational? Can anybody give me an example? Root 5 times what would give me a rational answer, meaning no more square root? Yes, Chauncey? Negative root 5? Root 5 times root 5. What happens when you multiply root 5 times root 5? Do they cancel out and leave you with just 5? Negative 5 in this case because there's a negative 1 there. So you are correct. Is the negative necessary? It's okay that you said it, but is it necessary? Is root 5 times root 5 still 5? So give me another example. If I give you root 7 times what? What would I multiply to be rational? Come on, guys. Root 7 times root 7, is that 7, which is rational? What if I gave you 2 root 7? Do I need to still multiply by 2 root 7, or is just root 7 enough?
Oh, what about...
Hold on. You found it? Give me a second. Is this enough? What's root 7 times root 7?
7.
And 2 times 7 is? All right, so do they have to be exactly the same, or is it okay to have 2 root 7 with the root 7? As long as the two radicals are the same. All right, did you find it?
I think so.
Okay, which ones?
So if you did 7 and 7 or something.
The 7 or the root 7?
I don't know.
Not sure.
Like A7,
A7, that's a 7 right there.
maybe 7.
And well, it does matter. Anyone have it? I kind of gave it to you when I did it on the other piece of paper. 2 root 7 and... Okay, I just multiplied those together for you. When we multiplied, what did we get? 14, and that's rational. Does that work for multiplying? It's rational. Add them, and it's irrational. What's 2 root 7 plus 1 root 7? 3 root 7. Is that rational or irrational? All right, so is it working so far? All right, now we want to find 2 so that when you multiply them, it is irrational, and when you add them, it is irrational. So it stays irrational both times. Yes, I'm ready.
7. Regular.
Regular 2 and regular 7? But I want them to be irrational. Is 2 plus 7 rational or irrational?
Rational.
And 2 times 7 is also rational. Okay, so that would have been correct if it had said rational. But I need them to be irrational. Anybody can give me 2?
7 and root 2.
Root 7 and root 2. Good job. Does that work? What's root 7 times root 2?
14.
Root 14. And is that irrational?
Yes.
And kind of a trick question. What's root 7 plus root 2?
Root 9, which is... What is it?
It's a trick question. It's root 7 plus root 2 is root 7 plus root 2. There's nothing you can do. Why? Because they're not like terms. Correct. They're not like, I can't add them together. They're not like terms. So, but root 7 plus root 2, even though I cannot simplify it any further, is it rational or irrational? All right, so root 7 and root 2 is a good combination. Questions? Okay, 19. Choose all the false statements. For the false statements, correct the mistake. I'm going to go ahead and let you guys work on that right now. You can check with the person sitting next to you. Just give me a minute. I want you guys trying it. Not free time. Put your phones away, please. Everybody asked that.
For 8, we're choosing 5.
So that's true or false?
Wouldn't B end up being, y negative 2 instead of y
And then if it doesn't have your exponent, you put ones on them, so it's 1 times whatever it is.
And then if there's no parentheses, then and remember, like, if it's like x is the third and like y is the second, you add.
They have to be the same.
Okay, then x to the third and y to the, or x to the fourth or something, then you add those together. Okay.
Guys, you're getting too loud.
Yeah.
Did you really?
I barely talked to her. No.
I do have food.
I want it.
I'm gonna eat it. Do you want some?
All right. All right. We're almost done with this, and then we are. Okay. Choose all the false statements. For the false statements, correct the mistake.
A, B, and C.
All right. First one, true or false? 6 divided by 2 is 3. That is true, but is that the way I do this? No. So select all the false. This is false. What am I supposed to do with the 2 and the 3? So 6 take away 2 is not 3. It is what? 4. And it's not 6. It is x. X to the 4th, not x to the 3rd. All right, next one. Do I add the powers or multiply the powers in this problem? And is 2 times 4 6? This is false. Where did the student mess up? What did they do with the 2 and the 4? Added them, so it should be y to the 8th. Gentlemen, I need you guys to stop, please. Okay, next one. When it's a negative exponent like that, I just bring the negative exponent to the beginning of the coefficient. Is that true? No. What do we do with the negative exponent? What does a negative exponent do to the base? It moves it to the bottom. If there's nothing left, what do I put at the top? 1 over b cubed. All right. Multiply is 4 times, oh, well, let's actually work it out. X to the what power? 16. Y to the what power? And there's another x. X to the what power? 4. And then what are we going to do with these two? What do we do with those exponents? Add the exponents. X to the what power? And y to the 12th. Is that true or false? So it's true. I don't have to mark it. I don't have to correct it. Questions?
What about E?
Yes, please. What about what?
E.
Oh, I didn't see E. Thank you. All right. What do I do with the power to a power? Multiply. And what's negative 5 times 4? And is that equivalent to b to the negative 1?
No.
No. What mistake did the kid make who did this one?
I did.
He added the exponents. Negative 5 plus 4 is negative 1. And is it negative 1? No, you multiply. All right, questions on that one?
Question.
Yes.
Are we done yet?
We have, I think, just one more, right? It went up to 20. Simplify the expression and then select all the expressions that are irrational. Want me to do this one? Yes or no?
Yes.
All right. 3 times 5. Remember, you multiply the outside, multiply the inside. What's 3 times 5? Square root of what's 2 times 13? When you're multiplying, they do not need to be like terms. 2 times 18. Did I say 13?
Yes.
Sorry. 2 times 18 is what?
36.
And am I done? Yes or no? Why not? Because it's a perfect square. It can still be simplified. It's going to be 15 times what? 6, which you can do by hand or plug in your calculator. Does anybody have it? 90. Rational or irrational? Because they did ask that.
Rational.
This one's rational. So we leave it alone. Okay, next one. There's no multiplying to do, so is this one done or can I simplify? Is this a perfect squared?
Yes.
So 7 times what?
6.
Which is
42.
rational or irrational? Okay, next one. Can I divide these two as long as they're both inside a square root sign? Yes, so what's root 15 divided by root 3? Is 5 a perfect squared? No. Rational or irrational? And is that what they were asking me to circle? All right, next one. 4 times, now the 2/3 is only on the 27. Do you see that? Not the 4.
Yes.
So when I write my radical, only the 27 goes inside. What goes right here? The cube root, and what goes as the power? 2. What's easier to do first, the cube root of 27 or 27 squared? Cube root of 27 is not 9. 9 times 9 times 9 is not 27. What is it? 3. So I have 4 times 3 or 3 squared. Before I go any further, is it going to be rational or irrational? How can you guys tell? There's no more square root, right? 3 squared is 9. What's 4 times 9? 36. All right. And the next one. Right now, written the way it is, can I add these two together?
No.
No, I could multiply when they're not like terms, but can I add them?
No.
No. That does not mean I'm done, though, because what can be done with 18 that I need to try first? Break it down. Good job. What does 18 break down into? 9 and 2, and 9 is? Can anybody do that quickly? If I have 2, 3, 3. 3 root 2. So 3 root 2 plus 5 times 3 root 2. That's getting really messy. I have 3 root 2 plus, what's 5 times 3? Plus 15 root 2. When I add like terms, does the radical undo each other? No. What's 3 root 2 plus 15 root 2? 18 root 2. Rational or irrational? Irrational. So C and E. Questions? We're good?